In the world of high-tech weaponry, when a prototype project is decommissioned, it usually meets its end in a scrapyard or a military museum. However, in March 2026, the U.S. Navy sent shockwaves through the defense community by revealing the reactivation of a high-energy laser system that had been killed off 2 years prior. This is the SSL-TM, a solid-state laser with a staggering 150 kilowatts output. After more than 6 months of restoration efforts at the Naval facility in California, this weapon was brought back to combat-ready status for the Crimson Dragon military exercise. This resurrection is not just a technical feat. It is a tacit admission of a grim reality. The Pentagon is facing a severe shortage of operational laser systems to counter the growing threats of drones and explosive-laden boats. Having to scavenge through storage to bring an old prototype back to life highlights the immense pressure the Navy is under to protect its strategic assets. To understand why the SSL-TM system is so valuable, we must look deep into the platform it once called home. The San Antonio-class amphibious transport dock, specifically the USS Portland, LPD-27. Unlike Arleigh Burke-class destroyers, which prioritize missile interceptors, an amphibious ship like the USS Portland offers ample space and abundant power, making it the ideal floating laboratory for directed energy weapons. Installed in 2019, the SSL-TM Mk2 Mod 0 represented a quantum leap in power, jumping from the 30 kilowatts of the older LAWIS system to a massive 150 kilowatts. This power level allows it to do more than just blind sensors. It has the capability to burn through the metal skin of a target in a matter of seconds. Its real-world performance was vividly demonstrated in May 2020 the Gulf of Aden, when it successfully splashed a target UAV, creating one of the most authentic representations of laser weaponry in actual combat to date. By late 2021, it further proved its multi-mission capability against asymmetric threats by neutralizing a small surface target. Although the prime contractor, Northrop Grumman, designed this system to be integrated into Arleigh Burke-class destroyers with minimal cost, the Navy unexpectedly initiated its deinstallation in 2023 after spending nearly $50 million on the project. The military's silence regarding the reasons for this removal left a significant void until the current urgent need for testing forced them back to this old flame to continue modern defense scenarios. The Crimson Dragon exercise in September 2025 served as the comeback stage for the SSL-TM, where it successfully destroyed 4 additional drone targets. However, behind this success lies a bitter truth regarding the scarcity of hardware. The report points out that while the U.S. is striving to field lasers at scale, it lacks enough physical systems to participate in high-stakes, realistic exercises. Other military systems are currently unavailable or preoccupied. The Army has completely demilitarized its 50 kilowatts DEM SHORAD systems, while other units are stuck on the Mexican border to intercept intruding drones. The Marine Corps returned its equipment to the contractor, and the Odin systems on destroyers are currently stretched thin in hotspots like the Red Sea. Even the promising 60 kilowatts Helios system has faced a challenging year, plagued by technical glitches. As a result, the Navy was forced to revive old prototypes to serve as aggressors for training and tactical refinement, fearing that otherwise, these exercise scenarios would exist only on paper. The SSL-TM's role in Crimson Dragon is projected to focus on sea point of departure defense, essentially protecting harbors or staging areas where troops and equipment prepare to embark. These are highly vulnerable targets of vital importance for overseas deployment. In an era where cheap Houthi drones can threaten billion-dollar warships, laser weapons have become the only economically viable solution. Each shot from the SSL-TM costs only a few dollars in electricity, compared to the millions required for a long-range interceptor missile. Relying on yesterday's prototypes to solve tomorrow's war equations reveals a gap in the procurement and maintenance strategy for directed energy weapons. The lesson from the SSL-TM is a stark reminder. In a volatile world, maintaining a diverse arsenal from expensive long-range missiles to invisible high-energy laser beams is the key to maintaining a global deterrent edge and protecting the fleets of a superpower across every ocean.